So in the last section, we learned about systems of equations, and we learned how to solve them by graphing. Now today we're going to learn a different way to solve them. So it's still the same type of problems, just there's a different method we'll use in order to solve them. And it's called substitution. So we'll be doing equations and plugging things in and solving instead of graphing. So to solve by substitution, we'll solve one of the equations for either x or for y. And it doesn't matter which one. Well, let me say it this way. Mathematically, it doesn't matter which one. There will definitely be times where it'll be easier for us to solve for x or for y, but you can do either one. Then, once we solve for x or y, we'll substitute that in for the same variable in the other equation. In other words, if you look down at this example here, which we'll work through completely, but what I'm saying is this one is already solved for e. I know it's not x or y, they use different variables here. But if we used, this is already solved for e. So since we know e is equal to 45 minus 8w, we can substitute 45 minus 8w in for this e right here. So we substitute in for the same variable, e, but in the other equation. Then we'll actually be solving for the other variable. So if you solve for x and then you plug stuff in the other equation, you'll find out what y is equal to. Then you'll plug that value into either of the two equations and solve for the second variable. So these are steps, but I know it's easier to understand steps once we actually are working through some examples. So let's do that with this first one down below. And there'll be plenty of times we're just dealing with equations, but I wanted to at least give an example of real life situation to start with. So the newest Mission Impossible to come out, at least as of this recording, was called Mission Impossible Dead Reckoning Part 1. It earned $45 million on its opening weekend. However, as often happens with movies, it earned less the following weekends. So it earned $8 million less than that the following weekend. Each of the following weekends. So in other words, its earning kept going down by $8 million over and over and over. Barbie, the movie, earned $39 million in its opening weekend, but it earned $6 million less than each of the following weekends. So the two equations below represent the earnings, so that's what the E stands for, the earnings of each movie, where W represents the number of weekends after the opening weekend. In other words, on its opening weekend, that's actually week 0, because that's 0 weeks after opening weekend. And if you plug in 0 for W, you get 45, which is what Mission Impossible earned on its opening weekend. If you plug in 0 for W here, you get 39, which is what Barbie opened to on its opening weekend. So plugging in 0 gives us the value for the opening weekend. Plugging in 1 tells us the value of the weekend after that. Plugging in 2 tells us the value of 2 weekends after opening weekend, and so on. So on which weekend will they both earn the same amount of money? So we've got to figure out when would these overlap. On what week is their earning the same? So we'll follow the directions up here. Now this one's already solved for E, so is this one. We could do it either direction, but just since this one is first, I'm going to say, all right, I know E is equal to 45 minus 8W. So I'm going to take that 45 minus 8W and plug it in for the E in the other equation. So this is why it's called substitution. I'm substituting this E with what it's equal to in the other equation. So I replace this E with 45 minus 8W, and I leave this side of the equation alone. I make no changes. Change to a darker pen. We have variables on both sides, so let's combine those. I'm going to choose to add 8W to both sides. Now I want to get that variable by itself, So I subtract 39 from both sides. 45 minus 39 is 6. Then I divide both sides by 2. I get 3 equals W. So that means 3 weeks after their opening weekend, these two earned the same amount of money. Now, we have found out part of the answer. We found out the first thing, which is on which weekend will they both earn the same amount of money. That's on the third weekend after opening weekend. But now it says, how much did they earn that weekend? So just like our answers with graphing ordered pairs, our final answer with these also need to be ordered pairs. So we've only found half the answers so far. Now we need to plug this back in, and you can do it for either one of these equations. You'll get the same answer either way. So I'll just plug it in the top equation. But if you plug it in the bottom equation, you'll get the same answer. 8 times 3 is 24. 45 minus 24 is 21. So our ordered pair would be 3, 21. And what that means is on the third weekend after they both opened, they both earned $21 million. So third weekend after opening. And this one means their earnings were $21 million. Okay. So we'll do the same method with these on the back. So as I look at number 1, again, you're allowed to solve for either x or y. Mathematically, it works either way, but there's certainly times one is easier than the other. So right here, this one's already solved for y. So why do any more work and try to solve for something else? I already know what y is equal to in this equation. It's equal to 2x plus 1. So I'm going to plug this into the y in the other equation. So I substitute 2x plus 1 in for this y. You don't have to put parentheses around it. I just make a habit of that because there's sometimes that we'll have a coefficient we've got to distribute. So that just helps me know, all right, I'm always going to put parentheses around it to make sure I remember to distribute if there's a coefficient involved. But there isn't one this time. So we do 3x plus 2x is 5x. Then we have plus 1. Then we subtract 1 from both sides. We get 5x equals negative 10. Then we divide both sides by 5, and we get x equals negative 2. But remember, this isn't our final answer. This is only half of our answer. You can plug negative 2 back in either one of these for x and find the value of y. So I'm going to do it in the top one. 2 times negative 2 is negative 4. Negative 4 plus 1 is negative 3. So that means the ordered pair where these two meet, the solution to the system of equations, is negative 2, negative 3. Okay, as we look at number 2. Now, none of the equations are already solved for one variable. Like in number 1, this one was already solved for y. This one, none of them are solved, neither of them are solved for a variable, but we want to figure out, okay, which one will be the easiest for us to get by itself? And it turns out the one without a variable tends to be the one that's going to be easiest to do. I don't really want to have to divide everything by 2, which is what I have to do if I solve for this y, or divide everything by 3 or 4 if I solve for one of these. That's going to lead to lots of messy fractions. It still works fine mathematically, but it makes it a lot harder to do. So I'm going to first take this equation and solve it for x. So I'll subtract 2y from both sides. And you can write it as negative 2y plus 6 or 6 minus 2y. Doesn't matter either way. Okay, so now I know what x is equal to. X is equal to 6 minus 2y. And I used this top equation to get that. So I need to plug this in for x in the other equation. So this is what I was saying about just making a habit of putting parentheses around things that I substitute in. Because this one I have to do 3 times x, so 3 times 6 minus 2y. And the rest of the equation I'll leave as it is, minus 4y equals 28. So I do have to distribute the 3 on this. 3 times 6 is 18. 3 times 2 is 6y. I can combine like terms. Negative 6y minus 4y is negative 10y. Then I can subtract 18 from both sides to get the term with the y by itself. And finally, I can divide by negative 10 on both sides to get that y equals 1. So we are halfway there. We've found the y value for the ordered pair. We also need to find the x value. So you can plug this 1 back in this equation and solve for x, or in this equation, solve for x. Totally up to you. I'm going to choose the top equation, so I get x plus 2 times 1 equals 6. Oh, and actually, I'm going to go and finish this first, and I'll tell you something. So x plus 2 equals 6. Oh, my mistake. Sorry. 10 divided by negative 10 is negative 1, not positive 1. Darn. So I need to plug in negative 1 right here. So I get x plus negative 2 equals 6. So then I add 2 to both sides. You could say x minus 2 as well. You get x equals 8. So the ordered pair, the solution to our system of equations, is 8, negative 1. So I'm glad I caught the negative sign, but what I was pausing to tell you before I realized that was I told you could plug the negative 1 into the top equation or the bottom equation, and that's true. But you can also plug it into this equation, and truthfully, using this one is usually the fastest because it's already solved for x. So that'll make it quicker to get the answer, because I'd get negative 2 times negative 1 is positive 2, and that pretty quickly gives me x equals 8. So you can plug it in the original equations, or whichever equation you rearranged in that form, you can also plug it back in. But regardless, our answer is 8, negative 1. Okay, on number 3. We could choose either way. We could choose to solve for this x. It has no coefficient, so it wouldn't be too hard to do. Or we could solve for this y, because it has no coefficient. It wouldn't be hard to do. Truly, either one is fine. I'm just going to do the top one just because that's been my pattern, but it's fine if you choose otherwise. So to get the x by itself, need to subtract 3y from both sides. Get negative x equals negative 2 minus 3y. Then I need to divide everything by negative 1 so the x is positive. So that gives me x equals positive 2 plus 3y. So now I know what x is equal to, so I need to plug that in to the x in the other equation. So I get y minus 1/3 times 2 plus 3y. So don't forget about that coefficient like I just about did. So I'm going to treat this as a negative 1/3. Negative 1/3 times 2 is negative 2/3. Negative 1/3 times 3 is negative 1. So we have y minus y, which cancels out the y, leaving us just two numbers. Negative 2/3 equals 2. As you likely know, that's not true. Negative 2/3 is not equal to, so we get no solution. Because it turns out these two are parallel lines. If you put them both in slope-intercept form, you'd find out they both have a slope of 1/3, and that means they're parallel lines, and there is no solution to this system of equations. And just to be clear about one other possibility, this one's no solution because when the variables disappeared, we got a false statement. But there can be times where when both variables disappear, you get something true, like 4 equals 4. That means you have the same line, and there'd be infinite solutions. Now, we did not have one of those come up on this set of notes, but I wanted to let you know, similar to when we were solving equations before, when the variables disappear, your two possibilities are no solution if the result is something false, or infinite solutions if the result is something true.